You guys, we apologize. We're the worst presenters ever. In every possible way, this is going to be the worst presentation you see at Black Hat, and we're very sorry. Among other things, all my pretty fonts in my slides are totally screwed because we're using my friend's laptop instead of mine. But real quick, before we were going to give this talk, we were talking upstairs. We did a couple of dry runs and came to the conclusion that if we hit every single one of our slides and spend exactly 50 seconds per slide, completely rock solid, we might get through this talk. Now we're 20 minutes in because of this, so I usually have a problem talking too fast, but under these circumstances, the only way we're going to get through the talk, so I'm just going to talk really fast the entire talk, and Dave will try to talk slow. So we're going to introduce ourselves, talk a little bit about what we're going to talk about, and then just get right into it. So Dave, shoot.
Sure. So apparently my microphone also isn't working. Can you guys hear me okay? Am I talking, like, I don't know, Tom sounds louder to me, so you guys got it? Great. Okay. Can't hear me in the back. I will try and talk as loud as I can without yelling. So we're here to talk about enterprise management systems and basically a combination of internal security, what's going on from an enterprise management system from a security perspective. Again, I'm going to be kind of going through this at as fast a pace as I can just to try and catch up some of the time that we lost. Quick company intro. Matasano, we were formed about a year ago. We're basically a digital consultancy.
We got a lot of material to cover. They don't care about who we are. I'm Tom. This is Dave. We're from a company called Matasano. Nice to meet you. We're going to go on.
Hi. All right, so what we did, we had a research project where we had the opportunity to look at a number of internal applications from a security perspective. And I'm going to keep inserting a little bit of our bios into this as we go through it. But we've been doing this for a long time. So we've been doing this for 10 years plus, finding vulnerabilities in different systems, starting from early days of Unix security up until today. So when we talk about internal, this slide is actually supposed to have labels on it. I don't know why they disappeared, but it's pretty much because that's my luck today. But inside of the blue were kind of external protocols, things that you'd see on the internet, things that you would deploy in your DMZs. And the important thing to know about what we were trying to communicate here was that, excuse me, it's pretty easy compared to, external security is pretty easy compared to internal security, right? From an access control perspective, you can put firewalls up, you can block everything except traffic to the services that you need. I know I'm oversimplifying it a little bit, but compared to the internal network, it's a nightmare. It's really challenging. There's a number of different protocols. Pretty much every one of those gray boxes was supposed to be one of them.
But we're thinking about things like SAN, storage, backups, management applications. I think people have this kind of intuitive sense that behind these firewalls, the applications that are running there are terrible. That if you have access to an internal network, it's pretty much game over. We started with that hypothesis and went on to try and prove it. And yeah, we're going to demonstrate in this talk one way in which that's absolutely true. So some of our core findings that we're going to elaborate on a little bit during this talk as much as we can. We released an advisory. I don't actually remember when on our iSCSI finding. We're basically able to bypass authentication to one of the major SANs. We broke lead DR projects. We've pretty much everything that we looked at, we pretty much tore through, is probably the easiest way to say it. Which is not a testament to how good we are as vulnerability researchers. We've been doing it for a while, but you're going to see a bunch of other people who are astoundingly better than we are in terms of ripping through applications. So, me versus HD is going to win every time. But you take a storage area network protocol and you back it out, reverse it, figure out how the protocol works, and then send malformed messages to it. And yeah, you expect the storage appliance to crash, it's going to crash. You expect to be able to bypass authentication by setting a bit in the login header? Yes, you're going to be able to do things like that. Disaster recovery protocols. Disaster recovery is slang for backup. She who owns backup owns the whole network. Yeah, we broke the market leading disaster recovery thing just by looking at it pretty much. So we're going to get back to this, but internal applications are horrible. And this talk is about a specific class of internal applications. So we'll probably save some time just by getting through this material fast.
Right. So, again, this is a justification slide. The reason why it's so crappy is simple. It's prioritization. No one's had to really think about the internal network. as much as they've had to think about the perimeter. That's where we think attacks come from. And then also, the way we handle internal security is through HR, right? Mostly firing people. The exciting thing, I think, from a researcher perspective, and maybe this isn't exciting, maybe it's the exact opposite, it's horrifying, is that when you're dealing with applications that are built to be deployed inside of internal networks, security is beyond an afterthought. It wasn't thought of at all. So for people that are tired of really having to struggle to find vulnerabilities in commercial applications and operating systems today, start looking at agent-based applications or internal applications, and you're going to find it's pretty easy. It doesn't take very long.
Pretty rewarding.
I think one of the things that shocked me when we went through this is how little has changed on the internal network. The same protocols that were there 10 years ago are there today. We've built more on top of them, but the old ones aren't going away. They're staying there. And they're just as crappy as they were. They have the same security problems they had. As a matter of fact, I think today we're releasing, actually Dino Dizovi in the audience, an advisory on AFP, which is Apple's file server protocol.
Raise your hands if you're in charge of securing the network of a graphic designer or one of the 3 people who use AFP. we own you completely.
But NFS is still everywhere internally. It's something that I haven't dealt with as a security professional on the external side in years. But when we start looking internally, it's everywhere.
But even the new protocols for internal storage aren't much better. Internal applications in general, if it's not deployed in front of a firewall, it hasn't been looked at. Nobody's tested it. Nobody's tried to secure it. These protocols are terrible. We'll skip this one pretty quickly, but network backup is a great example of, I honestly have no idea how to speak to this particular slide here. I'll apologize in advance, but do we have findings in network backup systems? Yes, we do. One of the problems you're going to see in this slide here is that we generally won't release things without patches. We're running 9 to 12 months backlogged with vendors right now. We've done 2. AFP is our second advisory that we've done so far. But we've got more than 30 backlog. It takes vendors forever, just absolutely forever to come up with patches. Our policy is we have a patch, we'll go forward and announce what the particular finding is. But so we have things in network backup, but if you have an NDA or I don't know, if you yell at us and beat us over the head, we'll tell you about it. But if you find it first, you can sell it. So that's great. Printers, another example of an internal thing that people don't think about very much, and I'd love to tell you about Printer Slammer and why you guys should be horrified about the possibility of printer-based malware, but right now I think we're just going to leave it at be horrified about the possibility of printer-based malware.
I think talked about it a little bit earlier, but from a research perspective, it's an interesting place to go. There's a lot of proprietary protocols to be looking at. There's a lot of reverse engineering that can be done. And then after doing a little bit of it, once you have the protocol figured out, you're going to start breaking things very quickly. It does not take very long. The hard part was figuring out how to get the data in there. Once it's in there, things just start falling left and right. And then if you're responsible for managing this stuff, I'm sorry to hear that, right? It's definitely not going to be easy. I think that this is going to be where the industry starts going. If you look at some of the recent vulnerabilities that people have been finding, you see people starting to focus on things like AV, and they're looking at antivirus agents. So you're beginning to see people start shifting towards things that you're going to start seeing on the enterprise. And one vulnerability that's identified in one of those can affect almost every machine inside of every company, right?
So we kind of blew through that really quickly. We're going to come to the second part of our talk where we actually start to try and get some focus about what we're talking about. We're here today to talk about a specific class of applications that run on pretty much everybody's internal networks. They're called enterprise management applications. And we'd like to explain what these things are by drawing a quick comparison. Which this slide, of course, is not going to work at all because we're on Dino's laptop, but we'll try.
So I think that the theme of this is pretty simple, right? The difference between a bot and a botnet and an agent and an agent management network is pretty much you pay a lot more for one, right? From a functionality perspective, they do almost the same thing.
which you suppose isn't a bad thing. They've dramatically eased the the burden of managing tens of thousands of machines. You suppose that it's inevitable. But the point that we want to make is that agent is a marketing term for bot. There's just no difference between the two of them in terms of what they do, what their goals are, and what the mechanisms are. So some examples of those mechanisms include, bots have command and control channels. They use things like
IRC, or I guess some of the more modern ones are getting a little bit more sophisticated, but you're still seeing IRC, which is the same internet relay chat protocol that people have been using for years to waste time and attack people there, have been using that same protocol to communicate with bots all over the world and get them to do distributed denial of service attacks, or expand their botnet by having their bots attack more systems and have them automatically extend their
because it's easy, and it's easy and it works. And IRC is an underrated protocol, but the guys developing the new botnet software, however those guys compete and try to make themselves sound cool and all that, those people wish for the kind of stuff that enterprise management vendors waste their money building. Middleware applications, message-oriented middlewares, highly sophisticated channels for conveying commands to tens of thousands of machines for minimal overhead, maximum transparency, the simplest possible way to get the commands out. These are both command and control channels. The difference is that one of them is proprietary and one of them is open source, and therefore one of them's been looked at and understood, and the other one, nobody has any clue what's running inside of them until somebody gets paid to go look under the covers and find out what's going on with them, which is something that we're going to talk about in just a second.
Right.
And so we come to the actual content of our talk. So, enterprise management applications, aka agents, aka bots. Are they a threat for you, or are they a menace? Well, we talked a little bit about what this stuff is and what it does. These are the pieces of software that the IT people put into the default build on all your machines, running in the system tray, running in the background, running as a process in the process menu. Things you don't even know are there, designed to be transparent, designs that people don't know that they're there. And what do? They make sure that you're up to date with the most recent configuration on your desktop. They make sure that servers have the right registry keys set. They make sure that you're running the most current revision of the software that you're supposed to be running. That's the purpose of these applications.
Tom, just one quick thing. DSM, what's the acronym?
DSM is just another marketing slang word for agent-based management applications. Stands for distributed systems management. It's the term that we can't actually use vendor names for vendors that we don't have patches for, but I'll tell you that there's a particular vendor that particularly likes this acronym, and hint, hint. So there you go, I'm just a jerk. So you could call this a snapshot of what the DSM market is, but really this is about the $1.4 billion US dollars market for bots. And here are some of the vendors in the space. IBM, Computer Associates with Unicenter, BMC with Patrol, Control-M, Change Manager, ConfigureSoft, BladeLogic, BigFix, a variety of vendors out there, all of which have essentially variants on agent-based management software. There's lots and lots of vendors in this space, and this, by the way, is not a list of the specific ones that we tested per se. There's at least one in here that we didn't test. So, but the thing to remember is that the leading vendor in this space right now, or one of the leading vendors in this space, has revenue comparable to Symantec. They make that much money selling agents that install on all these machines, selling bots, essentially. So here's something that I want you to remember as we talk about the different ways that we looked at these agent-based management systems and tried to break them and do things with them. And that's that the architecture for these things is essentially that you have tens of thousands of agents connecting to a single central management server, which is solely responsible for the security of all these agents. Every one of these agents runs with maximum system privileges, runs at operator level, runs at administrator, local admin, root, whatever. These are running with maximum privileges, and that central server in the middle is responsible for the security of absolutely all of them. If you think about agents as you would an SSH server, imagine a central machine in the middle that has all the keys for every single one of the machines there. Same idea. And then connected to all these are tens of people running admin UIs. They might be web browsers, they might be custom Windows applications that essentially pull data out of the agents and send commands back to the agents to tell them what to do. These are like the bot masters in their UIs, essentially the exact same idea. And if you want a picture, which actually might work, just to put that into a picture, right in the middle there you have a management server. It doesn't particularly work, but agents on desktops, agents on servers. These things all connect to SQL databases to hold the actual data that they're using. And then you have Win32 management interfaces or web-based management interfaces. And the thing I'm trying to convey by having this picture here is that there are a lot of different ways to attack these systems, a lot of different places that you can start with if you want to actually start trying to break in and taking over 10,000 machines with a single exploit.
I think another thing about that is also remember, internal networks, you don't have the same level of network segmentation, the same level of firewalling. So even though you saw a database there and you saw a management server, you may be able to connect to either one of those directly from anywhere on the internal network. I'm not saying every network's like that, but more are like that than you'd think.
This slide's totally just flat out not going to work, but I think you guys get the idea of one box in the middle, tens of thousands of machines that you get if you take over that single box, and what the actual penalty is. And remember, enterprises have more than one of these systems installed. Some places may be using Unicenter, some places may be using some totally different agent-based management system. And each one of them is essentially a botnet pre-installed for you by IT, and each one of them is a target for attack. You can go after multiple ones and get disjoint sets of machines. So let's start with the first and simplest possible way to attack these things. The agents themselves are waiting for connections from that central management server. So can we attack the agents directly? Well, yes, we can attack the agents directly. The agents are bound to a port. They're running clear text protocols. It's not SSL. There's no certificates being exchanged whatsoever. The only defense that these things have is they're running protocols that aren't documented. So the only defense they really have is that we're assuming that people aren't going to go and look on the wire or put a plugboard proxy in the middle and actually look at the protocols being run over that connection. And what are the types of things that we find when we're attacking the agent directly? Well, how about a protocol in which the very first thing you do in the protocol is send the name of the server connecting to you? And how about, let's do a time warp again, go back to 1995, and it's a Stack Overflow in the name. It's that simple. It's like the equivalent of a Stack Overflow in the get handler and a web server. I wish I could say that that never happens anymore, but on internal applications, on a particular storage vendor, buffer overflow, stack overflow, and the get handler of the web server. It's the exact same idea in the agent. Now, remember, if you take over one agent, you're now in a position to talk directly to that central management server. That central management server is going to talk to you. Aaron Bacham, are you making fun of me? Close my laptop. So one way we can attack these things, one place where we found vulnerabilities were there are very popular agent-based management systems where we can connect to the agents bound to a port, and we can send them traffic that's going to trigger a Stack Overflow, and we'll take over the agent. If we're in a position to talk through filters or whatever, talk to that central server, the exact same problem actually occurs, right? There are a variety of cases in which the agents are designed to connect directly back to the server to post, a new update, something new happened on that. Same type of problem. The vulnerabilities here aren't that interesting. It's the fact that these systems exist that you can attack. That is interesting here. So you can do the exact opposite, which is just connect to the server directly, and there are vulnerabilities that you can trigger there too. Specifically, look for things like Stack Overflows. Look for strings and fields that you can look for places where there's a string field and you stick a semicolon and a command after it, and the command gets expanded and run as if it was running through the Bourne shell. Happened with one of the major agent-based management systems that we looked at.
So another interesting form of attack that's, I wouldn't say it's unique to this type of architecture, but it's definitely something that's different than your standard kind of web-based client-side attacks, is that with agent-based technology, you're going to have management servers. You may even have the admin UIs connect directly to the agents periodically. It may be automated, but it's guaranteed that at some point you're going to be, if you control an agent, you are going to be in a position to attack the server when the server tries to pull information off of you or make some kind of communication request with you. So unlike in web environments where you have to be opportunistic and try and get people to wherever it is that you're trying to launch your attack from, or you have to compromise a server that's popular and extend that way, you are guaranteed in this situation that at some point in time, you're going to be able to attack that management server, you're going to be able to attack that admin UI.
And this slide got clipped, but at the bottom of that, we're coining a term for this type of attack. Client-side attacks in general, things like browser vulnerabilities. Actually, browser vulnerabilities are taken pretty seriously right now, but in a variety of situations, the client-side attack is kind of like a stepchild to the direct taking over the server. We have a new term here. We're calling them captive client-side attacks, and they occur a lot in agent-based management scenarios. And a captive client-side attack is simply a case where it's a client-side attack in that you're attacking the response to a request that somebody else sent you, but you're in a situation where it's deterministic. You are guaranteed to get that particular request. You've taken over an agent, and that agent is going to get the request that's going to come in, that's going to expose the server to the attack. So it's a captive client-side attack in that you're guaranteed to be able to pull it off. You don't have to coerce the server to talk to you. So are there situations in which if you take over an agent and the management server connects back to you, are there buffer overflows in the responses there? The answer to that question is yes, there are buffer overflows and the response is sent back to market-leading agent-based management systems.
So while something got cut off here, there's something I wanted to explain about the format of these slides. And again, we'll make sure that for anyone that can't see them, that you'll get copies of them, find us afterwards. But inside of each of these slides, we're going round by round through. You'll also see that there's kind of an anonymized advisory mentioned at the top of it. As Tom said, we're probably sitting on 30 plus security vulnerabilities inside of the space in general, with as many as 15 to 20 inside of one company alone. So what we're trying to do is we're trying to let you know that these aren't just things. We're not talking about this from just an architecture perspective, and these are the things you need to think about. We're saying these currently exist inside of enterprise management applications, and we know it.
So I know it's hard, right, for us to look at the slides and say, there are stack overflows here and there are heap overflows there and all that. But in general, I'm not sure how useful it is for you guys to see a hex dump on the screen of where an overflow is. It's more important to us that when advisories come out or when you look at this stuff, that you take the agent-based management systems, the central servers there, as extremely serious, high-priority targets inside of your enterprise. So here's another situation. This slide's really hard to read because of the fonts, but another vector of attack. The protocols themselves that are running there. Well, can we look at those protocols? If we can sniff, what kind of access do we get? Well, if we sniff the traffic between the agent and the management server, we get enough information to connect to the management server as any given agent, or vice versa. And we see all sorts of ridiculous authentication schemes. We found in a particular vendor a situation where we were able to connect to the management server, and there's a heap overflow in the connection message that you send. It's a 512 byte connection message they send with a fixed string in it. If that string gets too big, there's a straight up heap overflow in it. And it's Windows allocator, it's game over, right? And we send it to them and they come back with us and they say, we fixed the protocol. We now authenticate when people connect to us. And the way that we authenticate is we make sure that we're talking not to an exploit, but to a legitimate agent running the legitimate agent software. And I'm like, well, how do you do that? And it's like, well, we look at a magic number inside of the connection packet, inside of the connection message, that only the agent ever sends. Anybody want to take a wild guess as to how large that magic number actually turned out to be? 1 byte. Anybody want to take a guess as to which byte it was in the packet? The first byte in the packet was how they determine whether or not they're talking to a legitimate agent and they should trust everything they say. Now, I know 32 bits because we also, another ridiculous situation with authentication, there was a vendor that actually did a crypto-strong authentication between the client and the server, but that crypto-strong authentication produced essentially a cookie, which was a 32-bit monotonic cookie. And if you had that, you could submit subsequent requests as that authenticated agent. And those cookies started out at 0, so you could just start at 0 and scan up from 0 to 1,000, and you were guaranteed to get all the logged in sessions. Remotely, blind, without sniffing. You just talk to the server and you try each individual one until the message comes back successful. And then you pretend to log in. Generally, the way we exploit these types of vulnerabilities, because these sound pretty complicated, our general strategy for exploiting vulnerabilities like this is we build a proxy. We build a plugboard proxy that runs in between the legitimate management application, the web console, or the Win32 management app, or whatever command line crap they use to command these things, right? And we proxy the application through it. And there's a point in the protocol where that exploit is exposed. And all we do is the same thing we did with iSCSI. In iSCSI, there's literally a bit in the header that if you set it, that bit essentially says, I'm logged in. And we found the market-leading iSCSI server honored the bit in the header without actually logging in. You were able to just get into the server doing that. And the way we exploit that is we write an iSCSI proxy that just takes the login messages and doctors them So they always have that bit set in. So essentially what we get is a fully functional, legitimate client that has superpowers in that we've exploited it and then handed the connection back to it. Exactly what we do in this situation too. If I want to guess one of 1,000 cookie IDs, and then have a management client that can act as if it can log in as any user, that's how I'm going to do it. Is I'm going to write the client, or we did write the client, that just tries all those every time somebody logs in through that proxy.
And of course, just like perimeter applications, these applications are susceptible to all the standard implementation vulnerabilities that we've seen throughout the years. And it's even worse, right? Because a lot of times these applications were written years ago with even less security in mind, or no security in mind. So whereas stack buffer overflow, stack-based buffer overflows may be uncommon in applications we're all familiar with, on the internal network, common. Things like, as Tom was talking about, meta-character expansion, the ability to basically send in some data and have it get executed as a line inside of a Unix command shell, surprisingly common. So it was actually kind of fun for me because I got to take out basically parts of my toolkit from like 1993, and suddenly that knowledge became useful again, whereas I thought I was just kind of slowly becoming useless. So it was very exciting. It's like all my skills from 93 on are completely valuable again.
And that's just to those of you who've lapsed. You can get right back in on internal apps. So you think that the web server that controls the server that owns 10,000 machines on your local network, well, that would be a pretty good web server, a pretty good web application. JDEE and struts and all the other cool stuff, right? You think it would be better than, for instance, WordPress, my blog software? No. They have what we call cosmetic security in a lot of cases. They'll have a login page, and then, like every other bad application from 1999, you can just skip the login, go directly to the page behind the login, and that stuff works. The difference here is that once you do that, you're now in command of 10,000 machines on the internal network. So one thing to look at in agent-based management software is the fact that all of these things now have web-based clients and web-based management interfaces. And none of these web applications are any good whatsoever. Don't even get started on cross-site scripting. Right? It's a lame finding compared to what you're going to be able to do. SQL injection works absolutely everywhere. Forced browsing works on these stupid applications. So our advice about the web-based management interfaces of the most popular agent-based management systems is to turn them off. They don't work well. So definitely part of the moral of the story is if you've got people that are using these things, lock them down tight. Only allow certain people to talk to that management server, at least on those ports. You cannot leave those things exposed on your network. It's too tempting of a target. Why would you waste your time trying to install Agobot across an entire network, breaking into machines individually and spreading malware? The malware is already there for you. All you have to do, all you have to know is how to speak the right protocol, or what system to talk to, or what web query to literally punch into the URL bar in your browser to go and take over all those machines. So here's a fun attack vector. Basically, the purpose of these systems is for admins to pull information out of 10,000 agents running on these machines. The information coming out of those agents is trusted. It is the original source for all knowledge of what's happening in the network. When an agent reports its operating system as this particular version of XP, SP2, whatever, everything's trusting that. And if the agent reports that its particular version of Microsoft Windows XP is JavaScript alert high, somebody's going to see that information at some point. And if it's a browser-based interface, well, the trusted source of all the information can include all sorts of crap. It can include JavaScript, it can include SQL, which will often break things on the server itself. If you just put things in, it'll break SQL queries. Again, the information that the agents generate is trusted, both at the server and in the actual clients that are communicating with the server. In the Windows web management interface and in the browser interface, you can put JavaScript in the response that an agent gets, and you can take over the browser of the guy who uses the web-based management interface for the agent-based management system. The problem with that is that is a particularly valuable browser to own. Not only is that the guy who directly, overtly owns 10,000 machines network-wide, but he's also obviously a highly trusted IT admin, and you have his browser completely at that point because you were in control of the information coming out of the agents.
Well, and not only that, right? You're also talking about being able to, at that point, inject JavaScript into someone who is clearly at and has already logged into the management application. So it's not going to be too big of a step to write some JavaScript that's going to submit a URL to that and start executing commands to the management server just right through some simple JavaScript.
Because we got a little bit scrambled here, I want to make sure that we make a point that I don't think I've made yet. The number 10,000, for instance, is a meaningful number from a security perspective, that order of magnitude. If you want to start attacking these systems, if you want to come up with a scenario in which you end up owning 10,000 machines, you don't have to start with a Stack Overflow and the connection setup message to an agent. You can take over any one of those 10,000 agents with any attack. It could be a bad password, it could be an open share, it could be any possible attack that's going to get you local admin on a box running that agent. At that point, you're in a position to talk to the management server, and you're in a position to source information that's going to flow through the rest of the system and hit people in a variety of different ways. You can't possibly trust that any group of 10,000 systems on an internal network today is actually going to be secure. But that's exactly what these systems demand that you do. Because every one of them is trusted in exactly the same way to report the truth, or at least report information that isn't going to break the rest of the system.
Well, and it's also, I think Tom hit on this earlier, it's not just 10,000 hosts, right? You're talking about that's for each agent that is installed, each management system that's installed. And anyone here that works for a large organization, when your machine's loading up, you're not seeing one of these, you're seeing 5, you're seeing 6 of these get loaded up. So there's a lot of avenues of attack to go after different groups of machines, and just the breadth and depth of this problem is tremendous.
So we've talked a little bit about, and I've been cryptic and I apologize, about the ability to take, a management application, say, I don't know, I almost did it. But we've talked about being able to send malformed connection messages to an agent, or send a malformed connection message to a server. What about the fact that there's a Win32 management client talking to that server? Well, what's running in between that Win32 management client and the server itself? Well, it's not what you might expect. It's not like, on the back end, just XML RPC requests or something like that. No, it's some crazy, ridiculous, funky binary RPC protocol that these people invented themselves. So when I say these people, I mean all of them. Every single Windows management application that we've seen has some crazy new binary protocol, always built around RPC. Not every one of them, but always built around some kind of RPC concept. For instance, these people will take strings out of packets and they'll do Java, look up the class by its name and then call a method by its name. Ridiculous things that are trivially easy to break. So essentially we can repeat all the same attacks that we did before, but the important thing to remember here is that we're talking about a different set of protocols in the exact same system. These aren't the same attacks. Every one of the attacks that we talk about, you can usually multiply across every single connection in the system. So we have vulnerabilities where you can break the RPC protocol, for instance, that runs in between the Win32 management client and the management server. And the thing that you have to remember is that there is a different protocol, usually running on a different port for that particular connection, and it has to be secured separately. You have to look at it separately. You have to make sure that only the legitimate people, IP speakers, can speak that. Whatever you can do to lock that down. In a perfect world, what you'd be doing is you'd be doing TLS with client certificates, so that you can't possibly talk to the management server unless you're holding a certificate that proves that you're allowed to talk to that. But almost none of these applications even offer you the possibility of doing that. It's funny, even when they do offer that, the IT people who are installing these applications certainly aren't setting this up. Provisioning certificates to every one of them, everybody using a particular Windows management application, never going to happen. In iSCSI, you authenticate yourself by asking for a particular, they're called LUNs, and they have target names, right? But you ask for a particular set of disk with a particular name. And the protocol, authentication of the protocol is essentially optional. You have to turn it on. It's chat-based authentication. And we found this vulnerability, and we're jumping up and down like, we can bypass CHAP on these things. It's like, well, that's great, but none of our filers even run CHAP. They're all running just completely open. It's the exact same situation with a lot of these managed applications. Security is almost always optional. Vendors certainly do have the mindset that these things are running behind your firewalls, and therefore they don't have to, concern themselves with it. So certainly look at the documentation. Any optional security feature is off if the IT people set it up, because all these security features add headaches for the IT people setting it up. How are we going to?
We've got about 10 minutes before we have to start letting people ask questions.
Let's do this one really quickly, because I'm particularly fond of this. I don't know how many of you guys are familiar with Corba, but
Well,
Corba
raised his hand over there.
Corba is an object-based or an object-oriented RPC protocol. And Corba is the future if you live in 1996. And you guys are laughing, right? On a different version of this slide, we have the list of all the people who are publicly running Corba. Corba is running in places that you've never heard of before on these custom IT projects. There are vendors that use Corba as well, and Corba is totally broken. It's also not that hard to understand, and this slide again is messed up, but I think I can talk through it pretty quickly. You can map Corba to web pretty simply. And if you know how to attack a web application, and pretty much everyone knows how to bust web applications at this point, the exact same concepts apply. So Corba has a binary protocol called IIOP. And it is the worst binary protocol ever invented. It's awful. It's just a hideous, horrible protocol. But it's documented and there are public IIOP clients. IIOP is the total moral equivalent of HTTP. It does precisely the same thing. Corba has Corba messages that are sent to objects. A Corba message is an HTTP post request. It is the moral equivalent of an HTTP post request. It does exactly the same thing. Corba has what's called orbs. Orbs are one of the scary sounding things in Corba, but a Corba orb is simply the Corba equivalent of a web server. It's the thing that actually takes the messages in and sends them to the right instance that owns the object. Corba has objects. Objects in Corba are the exact same thing as web pages, as a page in a PHP application. A Corba object is a PHP page in an application. Corba has IOR. IOR is the Corba way of spelling URL. They're literally strings that refer to objects and arguments to those objects. On the web, we have DNS. Corba, for some reason, has its own naming system. It's called COS naming, and we're going to get to that in a second. And there's a variety of problems with that as well. Corba has methods. Methods are the moral equivalent of the arguments you tack on to a request to a PHP page. Corba has service context. Service context is a long way of saying cookie. Serves exactly the same purpose, works exactly the same way in a binary protocol, but is exactly the same idea as an HTTP cookie. And then Corba has a message body, and posts have post arguments. The point here is that all the attacks that you use to break a web application, putting meta characters in trying SQL injection, trying to go directly, this works everywhere, right? If you have a Corba application that's authenticated, you have to talk to an authentication object before you access anything else in the system. Well, just like in old web applications or internal web applications where there's an authentication page, but that's essentially cosmetic because you can just skip it, exact same thing applies. If you scan all the orbs in a Corba system, some of them won't check your authentication. You can talk to them absolutely. You can talk to them directly. All the same attacks that work from OWASP work in Corba apps. Of course, the slide isn't going to have labels, so I'm just going to speak to it. But it's an excellent attack. So, like I said before, Corba has its own name service. When you bring a new object up, that object has a name, and the guy who owns the object determines what the name is. It's like dynamic DNS. Except that it's dynamic DNS without any authentication. Without their dynamic DNS, without the COS naming service, none of Corba works. These Corba names are how people find other objects. So for instance, you have an authentication object that accepts messages, and if the messages prove that you are a specific user, they'll spit back a cookie back to you that you can use for other objects to prove that you've actually logged in. Well, that authentication object has a name. And the fun part about this is the orbs themselves that run the name service and the objects that implement the name service aren't authenticated. You can literally rebind the Corba names. You can forward all requests to the authentication objects to other objects, to you. You can man in the middle them if you want to. You can sniff all the actual authentication going through them. It's trivial, and it's part of the protocol in Corba. There's no authentication to the name service in Corba. So we've very successfully used this to break a particular Corba backend for a Win32 client talking to a management interface where somebody on that dev team thought, Corba is the wave of the future and we better, ride that wave. So we're able to go and take the authentication object or any other object in the system and hijack it or park the name for it and then man in the middle proxy it. And authenticate ourselves anyway. Again, what we're going to do here is we're going to implement a plugboard proxy that's going to run their standard Win32 management interface through our proxy transparently and give that proxy the ability to run as an arbitrary user and run without passwords. So This is a protocol level problem with Corba, and it's par for the course for internal RPC protocols.
Well, and I think it's also, this is another thing that it didn't take a lot of time to come up with this attack because people have already done this. This exact type of vulnerability existed inside of Sun RPC again in the early to mid 90s, and was used in almost the exact same way that we're using it today against an internal application.
The only thing that took a long time to find that vulnerability was actually realizing that could possibly be there. So you don't even bother to read the specs for the name service because it can't possibly be that you can just unplug anybody's name and plug it back into you. But it totally works. So agents talking directly to the clients, the Win32 clients, I said before that for the browser interface for these things, you can put JavaScript in them. If you want to try and corrupt the server with agent responses, you can put SQL in them. If you want to try and attack the Win32 client interface for these things, well, you generate really long strings. This is straight up Win32 code compiled without the GS flags or any of the compiler security by people who never, ever, ever thought about security. These are people who are plugging dialog boxes into Visual C, and that's hard work and all that, but it has nothing to do with securing software. So the simplest conceivable things, if an agent spits out an overly long string, you can take over the Win32 client. It's just like taking over the browser of the IT administrator that's running the application. We talked a little bit before, and we talked way too fast about the command and control interfaces in bots and the middleware implementations that allow the servers to talk to the tens of thousands of. And there's a variety of message-oriented middleware protocols that people use. An example that I'm not specifically talking about here would be something like TIBCO Rendezvous. Is an example of a message-oriented middleware protocol. TIBCO has other message-oriented middleware protocols as well. Now, one interesting thing about the message-oriented middleware protocols that connect to servers to the tens of thousands of clients is that they're a lot more sophisticated than IRC. You can do a lot more things with them. So they're a little bit more fun to play with, and they're absolutely just sitting there waiting to be a command and control interface for all the systems running the agents on the network. The other thing about these is that they're documented pretty well because they're sold, they're third-party OEMs to all the vendors that want to run them. So you can download the documentation for how, for instance, TIBCO Rendezvous actually works. But also, if you could take over the messaging layer in these systems, well, you have all the components talking to each other. You can spoof other client responses, you can inject commands, you can do all sorts of stuff. Plus, the message libraries themselves, the things that implement these message protocols, are libraries linked into the program. So if there's a buffer overflow in, I just got a new message from this name in the protocol, right? And if that name is too long and it triggers a Stack Overflow, that's linked into the library running in the agent or running in the server. So is it possible to break the message-oriented middleware layers in these systems? Absolutely, it is possible. We've done it. We have 3 advisories backlogged on this. None of these are particularly interesting advisories. They're straightforward attacks where if you go and look at these things, if you pull up the protocols in a sniffer or in a proxy and you find strings and you make the strings longer, you add AAA to the end of the string, you're going to find your EIP register at 0x41414141. Right? It's really simple stuff. You just have to know exactly which part of the system to attack. The message-oriented middleware layer, these are protocols that are bound to init or any running on arbitrary ports. If you just know the port to connect to and you send the right message, you've taken over not only that one machine, but the whole messaging layer for the entire. This is one interesting thing to think about, and I already mentioned a little bit already, but again, for some reason, even when people aren't using Corba, they all feel compelled to have some kind of application layer naming, where every agent and every server in the system has a high-level, user-visible name. And these names are registered. For instance, a new agent connects into this whole mesh of agents and servers and all that, and it registers itself, and its name is almost always just the DNS name of that system or whatever the Windows name is for that system. But for some reason, they have to have an application layer naming thing for it as well. And that name is how messages get sent to and from that agent, or to the server, the source for the message and all that. They're just like IRC nicks. It's exactly the same concept. And it's exactly the same attack. If you can cause any of the components in that system to crash, and you connect back to the server, and you register yourself with that person's name, you'll collide. Except that you're going to sit there and hold and park on their name, and then when messages come to that box, you're going to be able to intercept the messages in the middle of the messages and things like that. So any place where people do client-level naming, you have an additional attack where if you can DOS the server, or crash it, or crash the network, you can claim people's names and hijack them.
So, I mean, this one's also pretty straightforward. Actually, I'm going to kind of go off the map a little bit here because, we've been doing so well on time already. But one thing I just wanted to kind of communicate about what it is we're talking about, and then I'll definitely come back to this, is just that, think about the sheer number of protocols we've talked about inside of one of these. Like, Tom, give an example of like what's the most number of protocols you've seen in one given enterprise management application?
BMC Control M has the most number of protocols I've seen in any.
How many is my question.
I'm gonna off the top of my head say 8 or 9.
That's 8 or 9 proprietary or potentially proprietary protocols. I don't know. I'm not speaking for what's actually in Control M. I'm just saying, 8 or 9 protocols, some of which are proprietary, inside of one of these, and you've got maybe 5 to 10 of them running inside of your organization. That's a lot of proprietary protocols going around. That's a lot of untested code that's going around, and people are going to start looking at it a lot. Like, I really think that, as sure as I am that Corba is the way of the future, I'm sure people are going to be looking at this. The final thing, this is the final one. Right?
This is.
All right. So I hit on this earlier. Inside of internal applications, a lot of times they don't do the same level of segmentation. There aren't internal firewalls protecting things. You can usually communicate directly with the databases that are housing all of the information related with one of these enterprise management applications. They're often unpassworded, or they have a default password, and very few people have any idea that there even is a database password set up on one of these. I'm guessing that most of the administrators you talk to of these applications, 50-50 shot that they even know what the password is, or if there is actually one on the database instance for the application.
Like we've already said, I mean, I can think of at least one instance of an agent-based management system where there's literally multiple message-oriented middleware layers, each of them having all the same attacks as every message-oriented middleware layer. 2 sets of different naming contexts, 2 sets of different binary protocols, all the same stuff. So these systems are ridiculously complicated, and every wrinkle in these systems is an avenue to attack them. And 30+ advisories say these will actually work if you go look at them, and please race us and get advisories out, because it's taking us way too long to get these things disclosed, and it's bothering us. So why did we tell you all this? And why did we go through all this? Well, number one is that these systems are a threat. They're sitting there on your network. They're bots that you've already installed, just waiting to be misused by people. And if you run a network, your IT people have installed these things without you even knowing them. If you look at your desktops and you find these random little things listening on ports, they're asset management applications or configuration management applications or making sure your software is kept up to date, that kind of stuff. You have to treat those things as if they're incredibly sensitive, high-risk applications. You have to treat them as if they were the moral equivalent of Windows Remote Desktop. And why bother locking down Windows Remote Desktop and making it hard to get into different machines if you're just going to leave this back door wide open for you? So if you're an operator, if you're a security architecture, you need to be talking to the IT people on your network. You need to be cataloging what agent-based applications you're running, what are the agents running on your servers, how do they communicate, what are the different vectors of attacks there. And then as advisories come out, you're going to be more and more credible telling people, well, look, each one of these protocols is a possible way for somebody to take over 10,000 machines on our network. You have to be locking this stuff down.
I think from a vulnerability researcher perspective, if you're trying to help secure systems, this is an area that desperately needs attention, right? This is something that businesses rely on to operate their IT organization, their IT environments. And it's been just completely overlooked, even worse than the other things that we talked about earlier on in the presentation. We were talking about printers and things like that. This is a far greater problem, just that the amount of attention it receives is next to nothing.
So where are we at time?
We're at time to just, how many people have questions? Can I just raise a hand? Okay, so we don't have that many questions. We could probably go a little bit longer, but we're in like a 10-minute window.
We should just, originally, and there was minimal chance that we were going to get through this, even in the original set of slides. But I have these slides. We're going to publish these slides, and we're going to publish tools with them as well. But we wanted to talk about protocol reverse engineering. It's a hobby of ours, taking proprietary protocols and stripping them out and figuring out how they work, and all the ridiculous, crazy, stupid things that we find. Base 64 with the characters jumbled, XOR encryption, all this crazy stuff, and what we actually do about it. We have a set of really simple tools. We have a binary interactive netcat that lets us send arbitrary hex bytes to a connection, keep the connection open, shovel crap at it. We have a really nice, simple plugboard proxy. All these things are just, they're free. They're linked off of our blog. You can just download them and play with them if you wanted. We want to talk a little bit about that, but there's no way we're going to get through this right now. So we'll post the slides. They'll probably read better than us speaking to them anyways. So that's out there as well.
Yeah, and I'd also say that a lot of this section is also based on some of the posts on our blog. So if you go to our website, you can probably get some of that information directly and not in slide form, but more in a Tom Ptacek narrative. And why don't we just jump right into questions, because we're...
One other thing we want to talk about in terms of reverse engineering protocols, tools to reverse engineer protocols. Our partner, Jeremy Rauch, has a talk in a couple of hours. I promise Jeremy Rauch will be better set up for AV, and that we will see this stuff coming. But Jeremy Rauch has a protocol debugger. You can set breakpoints and protocol fields. You can single-step protocols. You can use it to reverse engineer protocols. You can use it to build your own proxies that will exploit vulnerabilities in protocols. We're releasing that today. We're talking to people about it. We have a talk about it. It's coming up next. Those of you who have questions. You're right. We said we haven't tested all those vendors. You want to give? That's a fair point. I think we just wanted to make sure that you're right. I'm sorry.
It's actually not one specific. You're being a little facetious there. So, but I address it.
You're okay with us naming your company? We can't say anything about the security of Big Fix, and Ryan's a smart guy, so I have high hopes that they've done a variety of things right. However, we've tested at least one agent-based management system designed for security, ironclad, rock-solid security, completely wide open. So write up a document about the stuff that you guys have tested. It's incredibly valuable to customers. They want to see this stuff. The people that are evaluating these things, figuring out how to deploy them, they want to know what the protocols that are running there. They want to know what kind of traffic is going through them. They want to know what the exposure is. So vendors like you, I agree. You're right. You guys aren't named in this talk as a target of ours. You guys should write out documents to inform your customers about what the protocols. That would be incredibly helpful. But Big Fix, good guys. Question over there. The question was, do we have any expectation of when the advisories will be coming out? What we have now are statistics about how long it takes after we publish exploit code to a vendor and traces through assembly code to how long it will take for them to get back to us. Our current estimate about that is infinity. I don't have a good answer. What I'd really love to find out from people is what are some better tactics that we can use to prod vendors along. So we have a variety of ways that they can come back on you and say, well, these are internal applications, or it's going to take us 9 release cycles to fix this pre-auth buffer overflow in a public service running on, bound to a network port. We're on a panel tomorrow about vulnerability disclosure. I hope to yell a lot about how hard it is to get things disclosed. It is the #1 problem we have finding new vulnerabilities, is figuring out ways to let customers know about them. We take every avenue that we can possibly get. For instance, sometimes vulnerabilities get fixed and they get put in the bug tracking databases.
I'm going to cut you off on this question just because the answer is we don't know. They're going to trickle out over time. We just have a number of other people have questions and I want to make sure we get to them. So this guy next.
If you're a Jericho believer, don't install agent-based management applications. They create a transitive trust situation where every machine is implicitly bound together and shares all the same credentials. It is the polar opposite of hardening every individual endpoint. I'm not a Jericho believer. I think firewalls and perimeter security has been one of the most successful things that we've done in computer security. It's the reason why the New York Times doesn't get defaced every day anymore. However, there's a lot of good thought that goes into the Jericho ideas of hardening machines, making machines survivable, and yeah, the notion of agent-based management applications, it's a good question to pose to a vendor as to how that could possibly be compatible with that goal.
Okay, then you. So.
No.
Absolutely not.
In fact, not only are they not limited to Windows, they're not limited to personal computers, they're not limited to servers. Mainframe runs some of these applications. the part of the value prop of an agent-based management application is it's cross-platform. It allows you to manage all these systems at the same time, and it allows you to take over all these systems at the same time. There are definitely Windows-specific agent management applications, but there are also heavily cross-platform agent management applications.
All right.
That's a good question. The question is, do we have examples of best practices or solutions or parts of solutions where agent-based management vendors have gotten it right? And I'll tell you that our answer to how agent-based management vendors can come close to getting it right has to do with locking down every endpoint in the system with TLS and client certificates. One slide, I just have to get to this slide because it's my favorite slide ever, and you can probably still see it. Vendors should not be allowed to write their own encryption. It's time we all stand up together, let facts be submitted to a candid world, ban vendor-implemented crypto libraries. There's only one answer for securing a connection and any new protocol that gets deployed. It's TLS with client certificates. The picture on the top there, the words top secret, the picture on the bottom is that same block, that same bitmap encrypted with ECB encryption. And you'll notice if you look carefully, you can still read it. This is what happens when you take the block function for AES and iterate it over a bunch of data in a for loop. The vendors don't realize they're using ECB encryption. They're just writing a for loop around the encryption function. It doesn't work. And the problem is not just that you can see through bitmaps encrypted with them. The problem is that you can cut and paste out of the messages and form new messages and replay messages out of it. The real solution that we need to see from vendors as a starting point is give us the ability to scope these applications down so that we can control exactly who's speaking to them, know that the people who are speaking to them. That doesn't solve the application level problems with them. The agents themselves, if one of the machines gets taken over, can still spit out data. And this is a huge problem. And the only solution to it I can see is that you scrub that data and you're really careful with it. But look at how good we are at scrubbing the data coming into any kind of application right now. But as a starting point, we should at least not let an arbitrary person who can just plug an Ethernet into a jack in a wall somewhere take over 20,000 machines on somebody's network. And I think the answer to that is to demand from everybody who does agent-based management applications that as a standard, everyone has to use TLS with client certificates as their primary means of access control. It has to be on by default too. If you make passwords optional in these systems, passwords will not be used by the IT people. One thing, the question is, do we review security applications as opposed to enterprise management applications? A valid way of looking at the space is to say that antivirus, for instance, is a great example of an agent-based management application or an agent-based security application. A lot of people are looking at McAfee, for instance, and I think it's a great thing. I think it's going to improve antivirus software, and I'm glad that people are looking at it. And I wouldn't be surprised to hear that those vendors are better at this than the random agent-based management vendors. We did not in particular look at them because we didn't have to. There's 50 other enterprise management applications that are already running there that are open targets. And the problem is that you haven't heard of them yet. And they're effectively, unlike antivirus systems, they are bots. They're designed to be bots. And what we're saying is, if you can reverse the protocols that they're using and send malware messages to them, you can treat them as if they're bots installed there for you to use. And when the advisories come out, that's what those advisories say, is with this vulnerability, if you've got this particular management application installed, you have a pre-installed botnet to use anywhere that you want to. It's a pass into those systems. So we didn't particularly look at security applications because we want to hit the ones that people haven't heard of yet. But yeah, there clearly are vulnerabilities in everybody's software, period. Securing software is insanely hard. My answer to that is that you should go look at IPMI and start looking at it carefully, right? Yeah. The question is, he hasn't looked at it, but, have we looked at things like IPMI? And I turn that back on you and say, why don't you come back to us with some IPMI findings? I guarantee you're going to find things in it. I think that, ECB encrypted bitmaps make us look cool and all that, but these vulnerabilities are not that cool. The problem is that they're ridiculously simple vulnerabilities, and we need to get the low-hanging fruit picked before we start moving on to other things. So, no. Nope.
All right, any additional questions?
You guys have been just great audience for us in spite of all the hardship that we've had here, and I apologize for apologizing 100 times about this. And I apologize to Ryan for implying that his company had vulnerabilities when I can't say that they don't have vulnerabilities. Thank you guys very, very much.
Thank you very much.